Picture a transport plane the size of a small office block easing onto a strip of bare gravel, the kind of ground no airliner would ever be allowed near. In its hold sits 37 tons of cargo, enough for an armored vehicle, a pair of stripped helicopter fuselages, or a complete field hospital. The same machine can throw more than 100 paratroopers out over a drop, zone, top off the tanks of fighter jets while everyone is still in the air, and dump 20,000 liters of water onto a burning forest in a single run. Then it settles back onto that same patch of gravel, rolls to a stop, and winds down 4 enormous turboprops. None of this is a proposal on paper. It is the Airbus A400M Atlas, and the story of how it gets built runs through 4 nations, a fleet of strangely swollen cargo planes, and one of the most demanding assembly lines anywhere in modern aviation. To understand why the Atlas was ever needed, you have to look at a problem European air forces simply could not fix with the aircraft already in their hangars. For decades, the backbone of European military airlift was the Transall C-160 and the Lockheed C-130 Hercules. Both were dependable, both had proven themselves over and over, and both had quietly run out of headroom. The Hercules could thread its way into short, rough fields, but it could not swallow the heavy, oversized loads that modern armies now took for granted. The bigger strategic jets could lift that weight, but only from long paved runways, far behind the action. Europe was stuck in the seam between tactical and strategic transport, forced to trade reach against ruggedness on every mission it flew. The decision that created the Atlases was a refusal to keep making that trade. In 2003, a group of European governments committed to a single aircraft that would cover both roles at once, and they handed the job to Airbus. What they asked for was close to contradictory. They wanted strategic range, the ability to carry a heavy load across thousands of kilometers. They also wanted tactical access, the ability to set that same load down on a dirt strip next to a flooded town. On top of that, they wanted airdrop, medical evacuation, and aerial refueling, all from one airframe. 8 partner nations eventually stood behind the program, and between them they ordered more than 170 aircraft, turning a list of requirements into one of the largest military aviation projects Europe had ever attempted. Turning that ambition into metal was never going to be quick, and the early years made the point bluntly. The Atlas program slipped behind schedule and ran past its budget, dragged down by the sheer reach of its mission and by an engine unlike anything in the Western fleet. Assembly of the first airframe did not start until 2007. The maiden flight kept sliding until the 11th of December 2009, when the prototype finally climbed away from Seville, in Spain. More years of testing followed before the first operational Atlas was handed over to the French Air Force in August of 2013. The aircraft that came out the far end of that long, bruising development was worth waiting for. It also was not built in any one place. Airbus does not assemble the A400M under a single roof. It builds the aircraft across most of a continent, with each location owning one part of the problem before the pieces are ever brought together. In Germany, at the plants in Bremen and Stade, technicians produce large fuselage sections and pre-build the hydraulic, electrical, and flight control systems that will eventually serve as the aircraft's nervous system. These are not simple bolt-on components. They are dense, tightly integrated assemblies, checked and signed off long before they leave the factory floor. France carries an equally critical share. The site at Nantes manufactures the center wing box, the single structural spine that links the wings to the fuselage and absorbs the punishment of every takeoff, every heavy landing, every ton loaded into the hold. The same part of the country supplies the radar and measurement systems, the sensors that let the Atlas read weather, terrain, and threats around it. There is no acceptable margin for failure in any of these parts, so each one is built and verified to a standard that treats the smallest defect as a reason to start again. Spain takes its own portion of the work. At the Tablada plant near Seville, crews prepare the engine fairings, the flap supports, and the horizontal tailplane, the surfaces that hand the Atlas its control and stability once it is airborne. What sets a modern Airbus line apart, though, is not only the hardware moving through it. The facility runs a deeply digital production system that ties workers, tools, and machines into one connected network, where information moves in real time and every operation is logged, measured, and tuned. It behaves less like a workshop and more like a single thinking organism. Then there is the awkward matter of geography. When the wings come from one country, the fuselage from another, and the tail from a third, you have to move objects the size of buildings clear across Europe and roads are not an option. Airbus solved that by building an aircraft whose entire purpose is carrying other aircraft. The Beluga, a transport so bloated across the top that it almost looks like a cartoon, was designed specifically to swallow oversized structures such as full wings and fuselage barrels. Watching one trundle up with an A400M wing tucked inside is a strange reminder that before the Atlas can fly a single mission, its own pieces have to be flown to one another. All of those components finally meet at the final assembly line at San Pablo in Seville, and this is where a collection of parts turns into an aircraft. The line is split into stations, each a specialist in one task. At Station 72, teams handle the marriage of the wings and the fitting of the engine pylons, the mounts that will carry the power plants. At Station 70, the airframe runs one of its least forgiving checks, where technicians search for the faintest trace of fuel weeping inside the wing structure, because on this aircraft, the wings are also the fuel tanks, and at altitude, a single leaking seam is not something you can live with. With the fuselage sealed and the wings mated, the Atlas is given its heart. Crews install 4 EuroProp TP400-D6 turboprops, among the most powerful turboprop engines ever bolted to a Western military aircraft, together with the auxiliary power units that wake the systems on the ground. After the engines come the avionics. Kilometers of wiring are threaded through the airframe, the digital flight systems are linked together, and the software that governs everything from the radar to the fly-by-wire controls is loaded and tested, then tested again until the aircraft responds exactly the way the engineers intend. Only after all of that does the Atlas receive its outer skin, the final paint, the national markings, and the protective coatings that will guard it against rain, salt, sand, and the steady beating of low-level flight. Then, after years of engineering and months on the line, it rolls out for a first flight that puts the whole effort on trial at once. That first climb is not for the cameras. Each of the 4 TP400 engines delivers roughly 11,000 shaft horsepower, and together they let a fully loaded Atlas pull steep tactical departures, hauling itself for altitude to break out of a dangerous area as fast as it possibly can. Even the propellers reflect that obsession with control. Each TP400 turns an 8-bladed propeller, and the 2 engines on each wing spin in opposite directions, a layout chosen to balance the loads across the wing and tame the torque of so much power. The aircraft also makes lift at low speed through a combination of leading-edge slats and large trailing-edge flaps, which is exactly what allows a machine this size to work out of fields that would trap a conventional jet. Power and lift are the 2 halves of the Atlas, and together they unlock the trick that defines it. Because the real point of the A400M is never the runway. It is every place where there is no runway at all. Riding on 12-wheel landing gear, with the soft footprint of a turboprop design, the Atlas can put 37 tons down on dirt, gravel, or grass, spreading its weight across soft ground that would bog down a heavier jet. That single ability collapses the distance between a supply depot and a disaster, between a rear airbase and a front line. Military and relief crews can reach remote sites that ordinary jet transports cannot serve, and they can arrive with armored vehicles, helicopters, or humanitarian loads already in the hold. Surviving in those places is its own engineering challenge, and the Atlas was built with it in mind. The aircraft can fly low mission profiles that keep it under enemy radar, leaning on defensive systems and precise flight controls to operate where the danger is at its worst. Its cockpit is armored. Its windshields are made to resist incoming fire. Its self-protection equipment is designed to give the crew a real chance in airspace that wants them gone. This is a transport built with the instincts of a combat aircraft. Just how low it will go is its own answer. The Atlas can descend to around 150 feet above the surface, skimming the terrain to stay hidden while still reaching the hardest points on the map. Flying that low leaves no room for hesitation and no time to recover from a mistake, and paired with its steep climb and surprising agility, it lets the aircraft drop into a threatened zone, deliver, and haul back out before anyone can react. The Atlas does not stop at moving cargo either. The very same airframe can turn into an aerial tanker, carrying up to 51 tons of fuel internally and passing it to fighters, helicopters, and even other transports in mid-flight. The aircraft that parachutes supplies onto a battlefield in the morning can, by afternoon, stretch the range of an entire strike package. It can also take on fuel itself while airborne, extending its own missions far beyond a single tank and quietly turning a tactical airlifter into a strategic asset. For airborne assault, it can carry as many as 116 fully equipped paratroopers in one mission, and it can make precise cargo drops from both high and low altitude, placing people and supplies exactly where a landing is impossible. In a sign of just how far the design will bend, Airbus has been developing a roll-on, roll-off firefighting kit that converts the Atlas into an aerial firefighter without any permanent change to the airframe, releasing 20,000 liters of water or retardant in a single pass against fires that pay no attention to borders. But carrying the war is only one half of what it means to build advanced military aircraft. Moving an army into position is one discipline. Winning the fight overhead is another one entirely. And while much of Europe poured its resources into airlift, a country on the northern edge of the continent was quietly building a fighter meant to hold its own skies against far larger powers, entirely on its own terms. That country is Sweden, and its thinking is unlike almost anyone else's. Sweden stayed out of the alliances that defined the Cold War, but it never confused neutrality with weakness. Instead, it built one of the most respected fighter traditions in the world, founded on a single uncomfortable assumption: that in a real war, its main air bases might be cratered in the opening hours. So Sweden refused to design a fighter for clean, intact runways. It designed one to fly from almost anywhere. In 1979, the aerospace and defense company Saab began work on a multi-role fighter that could fight in the air, strike targets on the ground, and run reconnaissance, all from one airframe. What emerged was the JAS-39 Gripen, a canard-delta fighter that looked like it had taxied out of a science fiction film, with small forewings set ahead of a sharp delta. Although the design reached back into the late 1970s, the Gripen would not make its first flight until 1988, after years of work to tame a machine that had been made deliberately unstable, and therefore extremely agile, controllable only through its fly-by-wire system. From the very beginning, it was an aircraft built around an idea, rather than around a runway. Saab does not build it alone. The company leans on a network of partners to produce the fuselage, the wings, the tail, the landing gear, and the weapon systems, with major sections made at different sites, and then shipped to a final assembly plant where everything is brought together. There, technicians integrate the systems that matter most: the flight controls, the communications, the navigation gear, and the sensor suites that turn a bare airframe into a frontline fighter. Everything about the Gripen serves the doctrine that created it. The fighter was built to operate from scattered bases under harsh conditions, getting airborne soon after engine start and a final round of automated checks, because in air defense, the side that gets off the ground first often wins the exchange, and it does not need a proper runway to do it. The Gripen asks only for a strip of road roughly 16 meters wide and 800 meters long, which means it can launch from short runways, taxiways, and ordinary public highways, dispersing across a country so that no single strike can pin the whole fleet in one place. Then there is the turnaround, and this is where the Swedish approach starts to sound almost unreal. The aircraft was engineered so that one trained technician, backed by 5 conscript mechanics, can refuel it, rearm it, and set it up for air-to-air combat in under 10 minutes. Every piece of support equipment needed to keep it flying from a temporary site fits inside a standard 20-foot container. This is a fighter designed to vanish into the landscape, work out of a forest road, and be back in the air before an enemy can even find the runway it never used. For all of that simplicity on the ground, the Gripen is anything but simple in the air. It can run air-to-air combat, ground attack, reconnaissance, and electronic warfare, switching roles as the mission shifts. Its delta wing and canards give it both stability and sharp agility, while the fly-by-wire system turns a pilot's intent into movement, a conventionally stable aircraft could never match. At the center of the latest Gripen E sits a sensor suite built for modern war. An active electronically scanned array radar and an infrared search and track system pour their data into a single, unified picture, so the pilot reads one clear battlefield instead of a clutter of separate displays. Just as importantly, the Gripen E was designed to share what it sees. Through secure data links, it trades information with other fighters, with command centers, and with friendly units on land and at sea, letting a pilot strike using targeting data gathered by a platform kilometers away rather than relying only on the sensors in its own nose. Controlling the electromagnetic spectrum can matter as much as controlling the sky, so the aircraft layers electronic countermeasures, jamming and decoys to detect, identify, and frustrate hostile systems while clouding the enemy's view in return. More than 4 decades after the original program began, Saab has unveiled the newest member of the family, the Gripen F. The first aircraft was rolled out on the 2nd of June, 2026, at Saab's facility in Linköping, Sweden, and it is far more than a trainer. The Gripen F is a true two-seat fighter, able to fly operational combat missions while also giving the next generation of pilots a realistic place to learn, with a second crew position that does much more than watch. That extra seat changes how the aircraft fights. Saab built the Gripen F so that workload can be split during demanding missions, leaving one crew member to concentrate on flying, while the other manages the sensors, the communications, and the flood of tactical information that defines air combat today. Even with the second cockpit, it keeps the same advanced architecture as the single-seat Gripen E, and Saab describes the platform as a fighter built to keep evolving, with an open design that lets new software, sensors, and capabilities be folded in as the threats change. How it was created says as much as the aircraft itself. It was not built by Sweden alone. It was developed in close partnership with Brazilian industry and the Brazilian Air Force, where the aircraft is designated F-39F, and hundreds of Brazilian engineers and technicians shaped the program through technology transfer and joint development. The first aircraft, carrying serial number 4000, will now move through a dedicated flight test campaign in Sweden before delivery to Brazil, since Saab has already drawn further interest from operators including Thailand and Colombia. That is the thread tying these two very different machines together. The A400M Atlas and the Gripen were built for opposite ends of the mission, one to carry the war and one to win it, yet both were created the same way, by nations pooling their industry, their engineers, and their ambition to build aircraft. No single factory could finish alone. From an assembly line stretched across 4 countries to a fighter that can scatter onto an ordinary highway, this is what it looks like when Europe sets out to build its most advanced military aircraft. And those production lines are still running because the next mission is always already on its way. If you made it this far, you clearly belong here. Subscribe to Air Power Files for a new military aviation documentary every week. Drop a like if this one held you, and tell us in the comments which aircraft we should break down next.